Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, editor. And this time I would like to present our project assignments. My name is Inam Shaukaini, and my metric numbers is GE 2020-0024. And then my friend's name is Nur Amni binti Adam, and her metric number is GE 2020-0028. Okay, going to the first slide. The slide is about outline of this project. First one is planning task. The second one is digital PID design, and the third one is results, and the fourth one is discussion. The last one is conclusions. Okay, let's go to the next slide. Okay, this slide is a planning task slide who describe the activity of the members in this group itself, where we're going to finish every single activity in every week. As we can see in the slide, from the first week until the last week, or from first week to the last week, from the planning, divide, and anticipating the task until submit the document text 3. And then next one is the planning task. In this the slide explains about the project completion flowchart. First one is we're going to start, of course, this project, and then going to planning and identifying and distributing the tasks between the member in the group itself. And the second one, and the next one is estimate the PID parameter and manual calculations based on the open loop system that we have built for the first time. And then next one is design PID control via Simulink. After we design the Simulink in the MATLAB itself, next we're going to testing, and then we're going to have analysis and discussions, and then the task is end. Okay, next slide is about open loop diagram. This diagram is the first process that we have to have we done for the first time, to have the output process of the system, where to have the good results. In this plot diagram, we input the input by 20 milliampere input. From there we will have the response of the system. Before I'm explaining about the results of the system, I would like to show the short simulations of the system in MATLAB. Okay, we're going to go to MATLAB first. Okay, that is the way how we can run the process of the system in MATLAB itself. And then next one is going to explain about the PID parameter estimations. And this slide show us about the process parameter using process reactions, or PRC, where the right side of this graph show us process parameter by using Nicholas method. And then this one is the above one of the process parameter is PID parameter, and then this parameter using okay, this part so as the PID parameter estimations, the results from the system, the previous slide. And after we running the MATLAB, we're going to have the figure 3, the process using reactive curve or PRC. On the left side of the figure, so as the obtain parameter from estimate process parameter from time delay, time constant, and process gain. And then the below of the obtain parameter is PID parameter, the obtain PID parameter by using a Nicholas-Ziegler tuning formula. And after we implement or apply the technique or the method, we'll have this all value. This all value that we expect to have for this project. And next slide will be explained by my friends.
Assalamualaikum warahmatullahi wabarakatuh, and hello to everyone. My name is Nurauni binti Adam and my matrix number is GE220028. So today I would like to present the digital PID block diagram, which is my part is the closed loop. As you can see at here, we use the temperature set point, and this is KP, which is proportional gain, and this one is KD, and this one is KI. And after that, we will put the saturation, and then we put the transfer function, but this one is discrete transfer function. And then we have the initial temperature, which is our initial temperature is 28, and there we will get the output with the scope, which is we can analyze it from the graph. So at here I will show you guys the MATLAB. So this is the MATLAB simulation, which is we have the step function, which is in the step function we put the parameters for the step time is 1, initial value is 0, and final value is 16, and sample time is 1. And then for our gain, we put the 2.3 to 2.23277, which is we already calculate at the Chinese part, and then at here we get the discrete time also, and then we put as 0.00223, and discrete derivative we put as 558.639. All of this measurement actually we already calculate at the first part. And next is our saturation. As we know, the saturation, we get the input signal, which is 20 milliampere. So that is our upper limit, and lower limit we put the 0. After that, this is the transfer function given, and the transfer function given is in the discrete, which is in Z transform. So that is 0.033773 over Z minus 0.9997, and our initial temperature is 28. So we run, and also we use this as 11000. So this is already done. So we need to open the scope, Okay, this one is our response. So we could get this. This is the cursor. So this one. So at here we could now we have the overshoot at here, which is the Cmax is 2.02 exponent 02 as the time, and the value is 6.363 exponent 01. So at by level measurement we could get the like pre-shoot, which is 0.562, and the overshoot 11.798%. So also we could know the settling time with the cursor. This one you need to put somewhere here, and then we could get like this. So it's about this is because I put the one at the behind, so we could know the settling time is at 20 if we put it like this. Also at here also we could get the peak time, but peak time is always already shown in this. Sorry, it's not peak time, it is rise time, which is we could get the 77.449 seconds. So next we will continue our slide, which is this is I already shown you guys, but this one I not shown, which is this is the positive 5% and negative 5% as the baud rate. So when the signal is finished at the settling time and it enter like this, so it has the baud at there. And also at here we have the at here we have the 90% and 10% for the rise time, and this is actually TS. So next is what we can get based on the MATLAB. We could get the transient response, which is the rise time is 77.449 measurement, and the peak time is 190.371, and the settling time is 1:1 for 0.915 seconds, and the percentage of the overshoot is 11.798%. So as we know, for the discussion, actually we could discuss in order to design the PID controller, as an open loop test was conducted on the system. As we know that we use the 20 milliampere input signal, so the discrete transfer function was used to determine the process gain, K, and time delay and time constant, and also the Ziegler-Nichols formula when then applied to obtain the PID controller gains, where the Kp was found as 2.23277 and also the Ki 0.00223 seconds, 223 over seconds, and the Kd is 558.639 seconds. And these gains were used in the design of PID controller. And then for this system, the set point was set to 16 degrees Celsius with an initial temperature of 28 degrees Celsius. The analysis revealed that the rise time TR, which represents the time taken to go from 10% to 90%, is 77.449 seconds, and also the settling time required from the output and stay within a 5% band was determined to be 1214.915 seconds, and the overshoot that found from this system is 6.67%. And as we found out with the overshoot, it is indicate to higher overshoot in this system response. So to improvement, oil to sodium berhad can implement various measures such as retune the PID gains and using anti-wind-up mechanism, applying saturation block, and considering advanced control techniques to achieve a smoother and more stable control system response. And from that, oil to sodium berhad can build the heating process of oil bleaching process from sembilan chemical with the best specification. So next is our conclusion. So as conclusion, all the tasks assigned in this group were completed, and the PID controller was successfully designed for the coconut oil bleaching heating process by using the MATLAB Simulink, and it provided the open loop test output response. Prior to design the controller, a discrete transfer function model was developed and used effectively. Also, the process reaction curve from the open loop test output response provide the necessary parameters for the design, and the PID controller was designed using gains that we obtained from the Ziegler-Nicholas formula, and consequently the design controller produced an output response for the closed loop system, which was then analyzed based on the specific requirements. And using measurement in MATLAB, the rise time, settling time, and the percentage overshoot were evaluated. However, the analysis revealed that the PID controller need further improvement in order to produce the response such as lower overshoot and fast settling time. And in order to finish up our project or assignment, we used the engineering 3rd edition Prentice Hall Library recommended books by K. Ogata, and the title is Discrete Time Control System. That's all from us. Thank you.